In this exercise, we have a data that describes the bicycle counts on Seattle's Fremont Bridge for people coming from the west and the east, as well as the total number of bike rides on each one of these following date times, right? So it looks like this data is collected at an hourly basis, at least from looking at the first few observations. Now with this data, we have some certain questions we would like to answer. Some data selection operations, such as extracting observations in a certain month, such as doing some data aggregation, what's the total bicycle count per year. Another data aggregation question, which is the average count per week, and what could possibly explain this variation. And then to answer the question, what time of the day is the busiest on the bridge? Okay, so let's take a look at the first question. The first question is to basically index the data by date, because that's the very basic operation we need to do in order to be able to deal with these values at date time values. So the first operation is to convert this from being string to being date time. This conversion is done using the function toDateTime. toDateTime is a universal function, so I can't pass in a list or a series of value to that function. I'm going to pass data date to this function, and the result will be a series containing the conversion of each one of these string values to datetime objects. I'm going to store this as a, let's call it a series, let's call it dates here. And the reason I'm storing it as a series is that I'm going to return to it in future questions. Now for this question, I want to set it to be the index. So I'm going to do data.setIndex dates. That's going to give me another data frame. And I have two options here, either to override the existing data frame or to create another data frame. I can call it data2, for instance, if I want to keep the same data frame. So what I'm going, for the sake of this exercise, I'm going just to create a new data frame. Let's call it data2, and we're going to use data2 here. And you can see that data2 has an index, which is a datetime index. Let's do the head so we don't dump the whole data into the notebook. Now it's asking us to extract the observations in the month of September 2019. Since the index is a datetime index, what I can simply do is data2 2019 09, and that will be it, because pandas will understand, since the datetime index, I'm looking for a subset of these values in which the beginning is 2009 09. So that's very handy, because now I don't need to do any other fancy operations to get. And we can see here we got 72 observation in September 2019. What I'm going to do in this exercise, I'm going also to show you how to solve these questions using the string methods rather than using the datetime functions. While this defeats the purpose of this exercise, it's kind of important because some people will have a better understanding and better familiarity with string than the toDateTime. So for some of the simple questions, such as the questions we have here, we can actually achieve the same result using string operations. So let me show you how we can do the same using data rather than data2. And data doesn't have that datetime index. What I'm going to do in data, I'm going to take a look at the column date, and the column date here is a string. It's not a datetime column. Okay, so what I'm going to do with it, I'm going actually to match September 2019 manually, because it matches 09 any 2 digits 2019. So what I'm going to do, I'm going to use a vectorized string function match, which matches a regular expression. My regular expression would be 09 and then digit and 2019. Now don't forget that match is all matching the beginning of the string, which is what I'm looking for. So that basically will give me a mask, and I can use my mask to select a subset from my data, and you can see that this subset it should have 720 rows, very much like the subset we got using the index. So this is another way to get to the same result using string operations rather than using datetime operations. Okay, let's take a look at the next question. The next question is asking us to count the total number of bicycles rides per year. And over time, are people using bikes more? So that's an aggregation operation, so we can aggregate by year, and then we can do the total number of counts. Now there are different ways to get to this answer. Let's take a look at some of these ways. First, let's take a look at data 2. And in data 2, I'm going to resample, and I'm going to resample at a yearly basis here. And then I'm going to do the sum when I resample. So I'm going to get the sum for each one of these here, and again I can take a look at the total here, because let's say I'm interested in the total number of bike rides, and I get the total per year. If I was interested in the average, so I can average it for each one of these years, and I can get another number here rather than the sum of all of these number of bikes. I get the average number of bike rides. The average is taking into account the number of observations per year, which I'm assuming are kind of similar over these years. But this is maybe important if we have some resampling issues. Maybe in 1 year we did not measure the bikes every hour, maybe every 3 hours. The average will take care of that. If we do the sum, we will get a systematic bias in that case. So either way, that's the average, which is 70 bike per hour, assuming I'm measuring on an hourly basis per year. So we can see that yes, in general, people are using bikes more, increasingly with time. Okay, so the other way to do it is using aggregation. Since the aggregation here is very similar, is using year, what I can do here, I can take a look at my data 2, and group by each year. So how do I get each year? Remember my series dates that have the dates here. This series contains datetime objects, so I can get to each one of them and take the year, because each one of these things is a year. So I can take the year of each one of these datetime objects in a series. What I can do with this series, I can use it as a group by condition. I can do data2.group by this thing. That's going to give me the group by object. And in this group by object, I'm going to take a look simply at total, because I'm interested in total here. And I'm going to take mean. And that's going to give me the average number of hourly bike rides per year. Put it this way. Okay, so we didn't get that. Let's see what, it's not data 2 or data. Let's see what's going on here. Let's count. So I had to do the group by on the original series here, on the original data frame here. Data rather than data 2. Okay, so that's giving me slightly different, the same numbers here, a slightly different number, the same numbers here, except that it's a slightly different index, because this index has been looking at the year end. This one is the year, but basically the same values for each one of these years. So if we list the values, we should get exactly the same values. The last way to do it is to completely avoid datetime operation once again. To basically extract the year here from the datetime string. So to extract the year in this nicely formatted string is pretty easy, because it's a sequence of 4 digits. So what I can do here, I can get to the column date in data, again that hasn't been converted yet, and what I can do with it, I can look at a sequence of 4 digits. So I'm going to do \d4, and that's going at 4 digits, so it's going to be a 4 digit for each one of these. It's actually date, not data, for each one of them. and it's going to return a list because, and generally speaking, you can, and when you do find all, you will get many of these, but we've got one here. So I'm going to do str0 to get the first element in each one of these. Once I do the year, I can store it. Let's call it years. And the second step is exactly the same as this one. Data group by year total dot mean, and that's give me the average per year. Years total dot mean. Okay. What's the average bicycle count per week? In this question now, we are forced to use date-time operations. We cannot extract the week from a date-time string using a string operation. So here we hit the limit of using string operations, and we need to look at this using date-time functions. We can take a look at each week in the date. So we can basically apply like approach number 1 or approach number 2. Approach number 1, we can resample to a weekly basis, and we can get each week in each year. That doesn't give me exactly what I want, because I want the week of the year in each one of these values. So I'm going to backtrack. I'm going actually to use approach number 2. And in approach number 2, I'm going to basically look at the week rather than look at the year. So that's basically the same code in here, but except then x.year is going to be x.week. And that's going to give me the week of the year. And we've got 53 of these weeks now in the data we have so far. So we can take a look here, and you can see that the data kind of peaks here in the middle of the year. So that's basically spring to early summertime, but then it goes down here, late summer, fall. So the variation is understandable here. It's basically seasonal variation here. And that's what you're seeing here. Now, what time of the day is the busiest on the bridge? It's kind of a similar question, but it's asking us to look at probably this data from an hourly perspective. We can do this per hour here if we wish, and do x.hour, and that's going to give me the same number per hour. And we got 24 hours, so we can see that the peak is in the morning here, as well as early in the afternoon. Late afternoon, it's where it peaks, so people are going to work and coming back from work, and that probably explains the variation here. Now we can do better than that. We can actually resample if we wish. So we can take a look at data 2 here, and resample for each 3 hours if you want to do in a 3-hour period. And then we can take a look at the total here, and we can do the average here. So we are basically resampling per each 3 hours in each day. What I'm going to do here, I'm going to take the sum. So each day now, instead of having data per hour, we do have data per each 3 hours. So then with this data, we can again group by each hour to get to a better understanding of the variation across the day. I'm going to call this hourly data here. Now hourly data is a series. So what I'm going to do, I need to get each hour per the index of the series. I'm going to take a look at the index and then map the hour per each index. Next, what I'm going to do with this thing, I'm going to do hourly data dot group by this thing. So that's going to group it per each hour, because I don't care about the date. I just care about the hour regardless of the date of the day itself. And then I'm going to take the average. And that basically will be a more downsampled version of this one, because this one is the average per hour, which has been the periodicity of the original data, and this is the average for each 3 hours. So we can see it's highest in between 6 to 9 a.m. and then even higher in between 3 to 6 p.m. That's where the peak number of bikes are on the bridge.